Hi everyone, my name is Jyoti and I'm working as Senior Scrum Master and leading two Scrum teams. Today I'll be talking about code smell, which is one of the technical depths. So what are we going to cover in this session? So we'll talk about technical depth, their type, and how do we identify technical depth. And then we'll, in the later half, we'll go and discuss more about code smells, their example, why they are of concern, how they get introduced, and what is it that we can do to prevent code smells, and what is the role of a Scrum Master in technical depth. Okay, so technical depth, these are your, and why, first of all, let's understand why they are depth. Because if we don't pay attention to these code and design depths, we end up doing additional work, right? And then additional work would impact our product delivery. So as a Scrum team, our focus is always into product development. So we have to see, out of say 10 days of work which we have, we want to focus 8 to 9 days in the product development activities. But with technical depth, what happened, our development speed reduces, right? Because there would be convoluted code, lack of documentation, because of which engineers are not able to understand what exactly is happening in the code, and that ultimately impacts our development time. Okay, so hence they are a debt. If you don't fix on time, you end up paying a higher price, and the higher price is additional rework, refactoring, and ultimately you have to stop for a while, you have to refactor your code, and you cannot proceed with your product development. Okay. So as a engineer, our focus should always be on reliable and long lasting solutions, rather than focusing on quick fixes or temp fixes just to resolve certain things. Okay. And how do you get to know about these depths? Through bugs or missing documentation. Now there are three types of technical debt. So first being planned technical debt. So as the name suggests, all the stakeholders are aware about these technical debt. For example, we have to push something to the market due to business requirement urgently, and because of that we cannot focus too much on writing the unit test coverage or completing your test automation. So that's a debt. We are going with that risk, so that the product could be marketed soon, right? So as a team, what should be your second step with respect to plan technical debt? Document it and make sure those gets prioritized in your upcoming sprint. Okay. Second is your unintentional technical debt. It's something which gets introduced because your lack of knowledge of the code, the coding standards, etc., which leads to these unintentional technical debt. So some of the ways by which you can reduce the technical debt is by having good automation coverage, or having matrices which are able to find out, okay, the number of lines of code which you've written. So if you see, oh, for particular class, the number of lines of code has increased from 150 to 180, for example. So that's something of a concern, and you can quickly understand, okay, why did we go from 150 to 180? Is there any way to break this down? Can we reuse certain things? Okay. uh, so static analysis, all these methods, they help you in catching these unintentional technical debt. Third being unavoidable technical debt. It's like you were using Java 8 and now there is Java 17 in the market, or Java 12 in the market. So because of that, the people have stopped supporting some of the methods or library. So because of that, you are getting a technical debt. Uh, could be you were using MD5 as a hashing algorithm. Now there is a new algorithm for hashing, etc., and you were not aware. Why you were not aware? Because you were not doing your code scan, and your only attention you were paying to was to a development work. Okay, so these are your unavoidable technical debt, dependency on the third party library. So you don't control what changes in that third party. But again, how can you avoid these? By regular doing code scans, etc., which can help you to find out these depreciated methods or libraries. Okay. So there are three ways by which you can identify technical debt, code smell being one of that. So today's session is all about code smell. So we'll talk about it in detail in the later half. Then code complexity. So you would have heard a term known as spaghetti code, wherein you have very convoluted code. Okay, so you've got a class, there's another class which is inheriting, there is parallel inheritance going on. So even code complexity causes technical debt. Okay. Third is your lack of documentation. Why lack of documentation causes technical debt, and what is it that companies are doing now to avoid these lack of documentation? For example, I've been asked to write a piece of code in existing functionality, existing code. Okay, so I don't know what is happening. There is no clear comment, like you don't have a clear comment, the name of the methods or a variable, they are not self-explanatory, there are a lot of unused variables, etc. So because of lack of documentation, person is not able to understand what's going on. So if person is not able to understand what's going on, what that person would do, he might end up creating another class, right, which already exists. But since I was not aware, because of the lack of documentation, I end up creating a duplicate code. Okay, so that's why you see nowadays you have readme.md file, etc., in the code, wherein you write stuff down. Okay, so one is like, okay, one time people do the documentation in wiki, etc., and then they forget to maintain. So the best way is to leverage your readme files, or have a better comment in the code. Again, you don't have to write too much of comment, but yes, sufficient comment should be there in your code. Okay. Yeah. So yes, let's understand what exactly are code smells. So these are like, they indicate a deeper problem. So take an analogy. Okay, one morning you get up, you open your refrigerator, and you see there is some smell coming. So that is an indication that there's something wrong. Either there's something wrong with the refrigerator, or there is something wrong with the vegetables you have kept, or juices you have kept. So they indicate a deeper problem. If you don't pay attention to that smell, what happened? Ultimately, you end up cleaning whole refrigerator, or you end up paying a higher price. Okay, so you have to call engineers to get those things resolved. Okay, so this is what happened with us. We saw that uh, our refrigerator was not freezing well, so we didn't pay attention to it, we ignored. And later on, when we got to know, oh, there is a problem, we called engineer. So that engineer was not able to fix that issue, another engineer was called, and ultimately now our refrigerator has become an unusable state. So if we would have paid attention at the right time, we might won't have seen this problem. Okay, so how do you identify code smells? Like, what are the different types, right? So you can have long method as a source of your code smell. Okay, you can have large class, large parameter list. So later I'll show you in a code scan which we had done. There we saw SonarQube, which is one of the tool which helps you to find out those code smells in your project. Okay, so that is used for Java. Okay, so for similarly for Python or other programming language, the tool would be different. So SonarQube we have used mostly for scanning our Java application which is written in Java. Large parameter list. So this is something which was like we were not aware of. Like, okay, you have a constraint of having just 7 parameters, because when you write those code, you don't get errors or warning for such things, right? It's like you are creating your method, you can use add as many parameters you want, right? But I think the best practice is not to have more than 7 parameters. duplicate code. So regarding duplicate code, there's a very interesting example which happened with us when I was part of automation team. So what happened, we had a piece, section of an application. So maybe that page was supporting 3 4 functionalities. So multiple engineers, automation engineers, were automating it. And so to locate the web element, we used to create locators. Now what happened, we were not aware that there are two people who are working on same page of the application. So I created my own locator, and then the other person created their own locator, and we used it. Everything was working fine. One day what happened, so this locator we used to create in an application whose backend was MySQL. So that MySQL got crashed, and we had to, and running a automation case which we called as build verification test. That was part of our release cycle. Okay, so for after every deployment we used to run this BVT to ensure that okay, the major functionalities are working on a high level. So with this crash we could not release our application. So it was decided, okay, we'll go ahead and recreate the locators, and we'll make our scripts up and running for BVT at least, so that we could be unblocked, and for regression and other type of automation test cases we can come back to it later. So when we started, what do you say, fixing those and recreating the locators, so whatever I had created, I what do you say, I recreated it. And we thought that okay, this is what we had to create. When we ran script, we found out failures, right? When we did the analysis, we saw, oh, for same particular line there's this another person who has created a locator with different name. So see, so much of like it, one day of work to make that BVT up and running took a week, right? So these are also your code smell, and this happens only when there is no coordination among engineers who are working on same piece of a code. Yeah. uh, Parallel inheritance hierarchy, which I told you, like okay, one class is inheriting another class, and then that class is inheriting some other class. So there's so much of inheritance. There's unused variable, you created variable and you forgot to use it. Okay. Dead code. Okay, so now we sunset a certain part of an application, and we forgot to do the refactoring and remove that section of code. So what happens with the dead code at times, you forget that because of that depth, those depth code, there could be a impact area, right? Maybe you were using some class or method of that dead code in some other piece. Okay, and you were not aware that okay, we don't have to support that code any longer. Okay, so these they ultimately take a lot of time to troubleshoot and debug that, oh, this dead code is causing the issue, and ideally we shouldn't have done anything on this dead code, it is of no use, we should have removed it or commented it. Okay. Then unsupported library, which I told you, because of upgrades or updates in the third party applications or software, uh, you see that some methods are no longer supported in your application, uh, starts erroring out. Okay, there is unreadable code due to excessive chaining. Again, say one method is calling some second method, that second method is calling some third method. Yeah. Exception logging. Okay, so you you have this concept, okay, to log all the exceptions. So what you do, you created a block for logging the exception, but you're not actually catching those exceptions. So what happens in those scenarios, if you see an error, you are unable to find out, you see some weird error messages or error code. Okay, which makes it more difficult to find out the exact root cause of the bug. Okay. And security flaws, same ways, you were using MD5 for hashing, and now there is another hashing algorithm which is being used, which is more secure. Since you were not aware about this upgrade, you continued using MD5. So these are examples of your code smell. So blotters, there would be your blotters, parallel bloaters, sorry. So which are like long method or large classes. Yeah. So here is an example of code smell, which we took on our application. So the tool which we used was Sonar Cube. And you'll see that there are like Sonar Cube gives you 5 categories of code smell: blocker, critical, major, minor, info. One thing to remember is as an engineer, if you see, for example, say remove this use, it is depreciated. You're seeing this data tag response is depreciated. So you have a choice to either fix this code smell or mark it not required, or we don't have to fix and add a comment. So code smell tool or this Sonar Cube would give you all the code smell which it finds with respect to the rules or standards which have been written. Okay, but you should not just focus on what is being shown as a code smell. You should always go and review, is it truly a code smell? Okay, at times we saw that we were getting error code smell as a duplicate code, but that was done on purpose. We had written that on purpose. So if somebody new joins in your organization and you've asked that person to fix the code smell which we have found out, make sure you tell them about these things, that they have to review whether, don't just accept the code smell or fix the code smell which they are seeing from the tool. They should always concern with the senior folks to understand, is it because of design, was it purposely done, or it was unintentional. So if it was unintentional and it requires fix, go ahead and fix it. But if something is done on purpose, we have created a duplicate code on purpose, then you don't have to fix it. Okay. Yeah, so majorly you will find duplicate blocks as a code smell, depreciated method as a code smell, or number of parameters which you are passing, unused variables, security flaws. So the SonarCube scans all of these and lists it down for you. Okay, and then you have to check each of these and do the needful. Okay. Yeah. So why code smell concerns us? By now you would have understood that they are technical debt. If they are not fixed, you'll end up paying a higher price in terms of additional rework or code refactoring. And here is a thing that it's seen that with refactoring, people end up introducing more code smell. Okay, then yeah, as I told you, development time increases. There is so much of convoluted code. I wanted to write just 2 pieces of a code, and then when we scanned, we found out, oh, in the same class there are so many code smell, undepreciated libraries, undepreciated methods, etc. Yeah, or this the looping which you were using was not correct. There were a lot of switch statement, or you were using primitive data type instead of so in Java, you have primitive data type like integer, boolean, etc. So it is recommended that since it's an object-oriented programming, everything should be used in the form of classes or object. Okay. So when you scan your code, you see these kind of code smells as well. Okay. Poor readability because of convoluted code and single point failure. So it takes us down to the same example. By a lack of documentation is a technical debt. So I was an engineer, I wrote that piece of a code, and once I leave the organization, nobody is aware what was written. Okay, so again we saw a severity issue a couple of months back, wherein the engineer who actually had written that piece of code had left and nobody was aware. So it took us more than a week to resolve that issue. Okay. So that's why it's recommended, have those documentations, have those KT sessions. Yeah. So how they are introduced? We are focusing on the temp fix. We are not seeing the larger picture. Okay, we just want to quickly fix and send code to the production. Second is there is so much of pressure to release something quickly. But here what my experience says, product owner or the other stakeholders, if you are being transparent with them and you tell them honestly that there is a risk of sending something quickly to a production, they do understand. So the idea is, if you see a risk, if you see a problem, don't be scared, don't be hesitant to call out, right? So you have to be transparent, you have to let people know. And as I told you that at times, because of the market need, we have to go ahead with that uh, code, right? But again, by letting the stakeholders informed, you avoid that pressure situation or a panic situation, because they know they took that call for going ahead with that production push despite having a technical debt. So if they encounter these technical debts, they won't panic, they won't the things won't get start escalating, because you have already informed the stakeholders about it. And parallelly, we have already planned in upcoming sprint that this is something we have to prioritize over any other. Okay. Third, not knowing the best practices. So this is what I suggest everyone is, it's, yeah, with your day-to-day coding, you learn a lot of things, but it's good to engage with community, it's good to read some blogs. Nowadays we have a concept of podcast, engineering podcast, etc. So you should always keep yourself updated, and you should be aware about the coding standards, what is clean code, and what do you say, various design patterns. Yeah. And finally, you're not scanning the code frequently, right? So not scanning the code means you're not aware that we have something called as code smell, or there are tools which can help you in finding those code smells for you. It's just that you have to integrate it with your code. Okay, you might have to update some dependencies in your POM file, etc. And that's it. So it would be a one time thing to integrate these uh, code scan tools with your code or CI/CD pipeline, or as simple as when you're doing development on your local, you have uh, uh, IDE, which is like your IntelliJ, Eclipse, etc. So have those plugin in those tools, in those IDE, so that when you're writing, it gives you those code smells then and there. Okay, rather than getting it scanned it once you merge it to your code repository. Okay. Yeah, so how can we prevent code smell? So some of it I covered in the previous slide. Have a sonar lint, which is one of the plugins for ID. Scan your code locally. um, Reserve bandwidth every sprint. Okay, so now, for example, we integrated our code with these Sonar Cube, etc. after a year or two, right? So make sure you reserve some bandwidth for fixing the previous code smells, and parallelly with current development which you're doing, use Sonar Lint, etc. to scan your code locally. Third is code review and peer review. Try to uh, so while giving estimation to a story, keep some time for the code review or a peer review. Okay, so in code review also, if you have enough time, you can find out these code smell. In some future sessions, I'll be talking about what are some best practices for code review, how you can have effective code reviews. For example, at times what people do is they create a single PR, which is like pull request, piece of code which you have written which needs to be approved. So instead of breaking it into smaller PRs, yeah, or small pieces of code, what they do is, okay, they create a single pull request and they'll write those multiple, they send all the changes which they have done in multiple files. Say there are 5-10 files in which you have done the changes, and the person who is reviewing, they didn't they are also working on their development work, right? And they were not aware that okay, in the last moment you'll be sending something. So what happened is, now the person who is reviewing your code, he'll just do a quick scan, right? But if you divide your complete work into small chunks and you keep giving it for review, so it would be easier for the person to review the code as well. Finally, it is found that chances of introducing the code smell during the initial phase of a code development is more. So that's why it is recommended to have spikes in the sprint, and to pay attention to the designs, right? So pay a lot of attention, get those designs review. Okay, should we use Couchbase, should we use Postgres? So all these things you need to discuss initially, okay, and study about their pros and cons, and then go with actual implementation or coding. Yeah. And have some matrices which can, what do you say, radiate that information for you. For example, lines of code. So you have got some tools which tells you, okay, which class has how many lines of code, and something is pushed to that code or that repository, and you see there is increase in the lines of code. So that is also one of the ways you can prevent code smell. Now, the question comes, what is my role or our role as a Scrum Master? Um, to educate the development team or to the product team that yes, it's good to produce new feature, okay, but it's also necessary to ensure that team picks technical depth, and we reserve some capacity for those things, okay. Conducting frequent workshop, have those workshop where we talk about design patterns, the latest changes which is happening in the engineering, the changes to the version of the Java. So I have those tech talks or workshop around these topics, and just not focus on product delivery, okay. Again, quality versus quantity. Do you just want to push things to the production and keep on releasing the changes to the production because of market demand, or you want to push a quality code, right? So it's not necessary, but mostly what happens with startup, they are more into quantity, right? But ultimately then after 2-3 years, they see the impact of focusing on quantity and not quality. Yeah. And yeah, also automation is everywhere. So yes, integrate code scan as part of your CI/CD. So those through CI/CD only, if you forgot to do a local scan on your local on your machine, or it was not caught in your peer review or code review, so the CI/CD can help you. Okay, so you can integrate your SonarQube with Jenkins, right? Or SonarQube with your Bitbucket or GitHub. So which regularly scans your code, and they give you, okay, this is vulnerabilities in your application. These are your code smells. In those code smell, what is the critical one? What is the blocker one? So yeah, so this is all about today. uh, so probably in future we can talk about code reviews, like how we can have effective code reviews, and what is it that as a reviewer one can do, and what as a person who is raising those review requests should take care of. Because that is also one area, if you pay attention to and enough time is given, you end up avoiding these code smells or technical debt. So yeah, that's all. Thank you, everyone. Feel free to share your questions or queries in the channel, and we'll get back to you with the answers. Yeah, bye.